Right. So this is our first live stream. I hope everything is okay with the quality of the video. And so today's topic is going to be factoring polynomials. And if you look at the link there, it's available if you want to download it as a PDF file. It's at my website, terrysmathtutoring.com/downloads/livestream1.pdf. And there you should find this file right here. And we're going to go through all these questions. And we're going to learn how to factor polynomials. We're going to learn common factoring, grouping, trinomial, and difference of squares. And then at the end of the document, there's answers. So this is our goal for today. So let's just talk a little bit about what we're doing here, introduce the topic a little bit. So factoring polynomials. So roughly there's 4 different kinds of factoring. The first one is common factoring. And this one, just by the name of it, not surprisingly, it's the most common, most typical kind that you'll see. And there's also, let me just adjust my microphone here. The next one we'll talk about is grouping. And then we'll talk about trinomial factoring. And for that one, there's going to be two branches, two types. The first case is what I would call A = 1. I'll explain what this means later. And this is the easy. This is one's easy. And then the other style is when A is not equal to 1. And this is a little bit harder. And for this one, we're going to use what's called the decomposition method. And then the fourth kind of factoring is difference of squares. So just a little comment for grouping, it's going to have 4 terms, your polynomial. Trinomial, the word tri, of course, means 3. So that's going to have 3 terms. Difference of squares is going to have 2 terms in it. And common factoring really could have any number of terms. It could be anything. All right. Let me just check the stats here, make sure everything's okay. All right, so let's keep going. So what does it mean to factor? So factoring means to write as a product. You know, if I ask you to factor a number, let's say to factor the number 15, what does that mean? It means to write 15 as a product of 2 other numbers. So maybe you could write 15 as 3 times 5. Now, maybe we're used to writing 3 times 5 using the x for multiply, but usually at this level of math, we stop using the x. And it's maybe better to write a dot. Or even better, write brackets. So there's a factorization of 15. It's written as a product of two other things. Now, of course, I could write 15 as 1 times 15, but that's kind of not interesting because it's too simple. Obviously, any number is 1 times itself. More interesting is this one I wrote up here, 3 times 5, because it's breaking it down into smaller things. So we're going to be doing the same thing, but not with numbers, with polynomials. Okay, so that's just an idea of what factoring is going to be. Really, it means to write your original polynomial as a product of other polynomials that are in some sense smaller, usually in smaller in degree. Okay. Now let's just warm up by let me ask you this question. Let's say I ask you to simplify something like this. 2x times, I don't know, 5x plus 3 or something. So here, this is actually already factored. I could put brackets here maybe. I don't really need to because this is just a monomial. But if I ask you to, when I say simplify, I kind of mean multiply it out. And so this 2x is going to multiply to the 5x, and then it's going to multiply to the plus 3. This is called the distributive law. And this is something you should kind of be familiar with already from the previous grade. So 2x times 5x, 2 times 5 is 10. And what's x times x? It's x squared. And 2x times 3 is 6x, and there's a plus there, so it's a positive or a plus 6x. So this is something that we learn before factoring. And factoring is actually the opposite. It's like I'm going to give you this expression here on the right-hand side, and I want you to make this expression up over here. So factoring is the opposite of this. So I would give you, excuse me, I'd give you the expression on the right-hand side, and your answer would be this expression on the left-hand side. So it's a little bit harder. So let's start practicing some questions, and we'll get a feel for this. So I'm going to take the first questions on this question sheet here, and let's try it some here. So here are the first few questions. So on the very first one there, 4x minus 10, this is common factoring. This is the first kind of factoring we're going to learn. We look at each term and we think what's common there. What number or what quantity can we divide each term by? And that would be the number 2, right? 2 goes into 4 and 2 goes into 10. So it's kind of like we can pull out a 2 to the front here. And then we got to think what goes in the brackets. So 2 multiplied by this needs to turn out to be 4x. And 2 multiplied by this needs to become negative 10. So if we think about that, 2 times what is 4x? That's 2x. And of course, 2 times what is 10? That's 5. And there's a minus sign here, so we need a minus sign there. And that's our answer. I could put brackets here, but since it's just a single term, I don't need to. I'll leave the brackets off. All right, so number 2 here, x to the 5 minus 2x cubed. What's common there? Notice there's no number that we could divide out here, or we could pull out to the front. There's no, other than 1. There's a 1 here. You can always imagine there's a 1 there. But if 1 is the only thing that's common, it's kind of like there's nothing in common, and we don't pull nothing out. But here we can pull out a power of x. The variable is common here. And the way that works is you can always pull out the lowest power of x. So that would be x cubed here. So let's imagine we take x cubed and pull that out to the front. Whenever we do common factoring, I always kind of imagine we're pulling something to the front. And then we get a set of brackets afterwards. And the thing in brackets here will be simpler than what we had originally. This x cubed multiplied by whatever goes here needs to be x to the 5. And then x cubed times whatever goes there needs to be 2x cubed. So if you remember the rule for adding powers, you know, if you have like x to the n times x to the m, that's how do you handle something like that? You add the exponents, right? So whatever goes here, the 3, this is going to be x to some power. And 3 plus this needs to be 5. So that has to be a 2. X cubed times x squared is x to the 3 plus 2, which is x to the 5. And then minus x cubed times what is 2x cubed? Well, that's just 2. And there's our answer for that one. I'll just erase this. All right, number 3, 3x squared minus 12x. So here, notice on this one, we could only pull out a number. And on this one, we could only pull out a letter, a variable. But in this one, we can pull out a number and a variable. So if we kind of think of them separately, like 3 and 12, what's the largest common divisor of 3 and 12? GCD, greatest common divisor, that's 3. So we could pull out a 3. And then we look at the powers of x. We have x squared here, and here this is x to the 1. Even though there's not a 1 written there, we should know that there is a little 1 up there. And between 2 and 1, 1 is smaller. So we can pull out an x to the 1. And then what goes here? Well, 3x times what is 3x squared? That's x. 3x times this is 12x. So 3x times what? Well, that's going to be a 4. So our final answer here for factoring that little guy is just 3x times x minus 4. All right, so number 4, let's factor this. So between 5 and 20, 5 is common. Between x cubed and x squared, what's the largest power of x we can pull out? That's x squared. And 5x squared times what is that? That's just x. And 5 times 4 makes 20. Notice I put a plus sign here because there's a plus sign there. And since the x squared has been pulled out, there is actually nothing there. So maybe I'll put this bracket a little bit closer. Okay, so number 5. 2x squared. Notice on this one we have two variables here. We haven't seen that yet. All of these have been just one variable, but now we have an x and a y coming in. So what can we pull out here? Well, a 2 for sure. And 2 goes into 2 and 2 goes into 16. It's like I do each one separately. I look at the 2 and then I look at the x and then I look at the y, and I always try to pull out the lowest exponent. So between 2 and 16, I can pull out a 2. X squared and x, I can pull out an x. And y squared, I can pull out a y. And then what goes in there? Well, when I do 2xy times what, it gives me that. That's going to be x. And 2 times 8 is 16. So I have an 8 there. And then the x has already been pulled out. One copy of y has been pulled out. So we have one copy of y left over there. So we get 2xy times x minus 8y for that answer. All right, number 6, the last one here on this little section. Notice on this one, we're leading with the negative sign. And often when you have a negative sign out front, you should pull out the negative. So this is like a -1, eh? So you can pull out a -1. There's really a 1 here too, if you want to imagine that. So we're going to take out a -1. You could write -1, but usually we don't. Usually we just write a dash. A dash means -1. And then the lowest exponent here is x cubed. We can't take out a y though, because y is here but not there. So let's think about what goes in the brackets here. Sometimes students get a little confused right here because we pulled out, we have minus x cubed here and we factor out minus x cubed. And they think that, students sometimes think there should be nothing there, but that's not true. Like minus x cubed times what is minus x cubed? It's 1, right? And that's very important to put a 1 there. We can't leave it empty. Like leaving it empty would kind of mean like it's a 0. And then there's something tricky here as well. Well, first of all, we've taken out 3 copies of x, so there's going to be a single copy of x left. And this y wasn't touched at all, so that's still there. And then the slightly tricky thing is, what's the sign here? It was plus, but since we pull it a minus, we have to think minus times what is plus. That's actually going to be a minus. So minus x cubed times 1 is, of course, minus x cubed. And minus x cubed times minus xy. The double minus makes the plus. X cubed times x is x to the 4, and the y is just sitting there. So there we go. So that's the questions 1 to 6 there. Let's keep going on our PDF. So the next little section here is these 3. Let's grab these. These ones are looking a little bit harder. Right. So let's take a look at number 6 here. Sorry, number 7. We'll just copy the question down. It's really the same idea. Notice on all these were all 2 terms. And these are 3 terms. But like I said at the beginning, with common factoring, it could really be any number of terms. So we look at the numbers. These are called coefficients, the 6, the 2, and the 4. 2 is common. Let's pull that out. With the powers of m, the lowest power is m squared. Let's pull that out. And then the lowest power of n is n squared. Pull that out. Since this had 3 terms, we expect there's going to be 3 terms in the brackets here. So 2 times what is 6? That's a 3. We pulled out 2 copies of m, so there's an m there. N squared has been completely pulled out, so there's nothing anymore to write on this guy. And then we have our minus sign here. The 2 has been pulled out. The m squared has been pulled out. And with n cubed, we've pulled out 2 copies of n. So there's just an n left there. And here with the 4, the 2 has been pulled out. The m squared is gone and the n squared is gone. So it's actually just a 2 there. And there we go on that one. So number 8. 9xyz 3x squared y. My cursor, when I did a screen capture there, my cursor was over top. That's a 6. I just looked on the sheet there. So in this one, we actually have 3 variables. With 9, 3, and 6, 3 is common. We have an x in all of these, so we can plot an x. We have a y to the 1 in all of them. But notice we have a z in this one and this one. We don't have a z there, so we can't pull that out. All right, so we have a 3 here. X and y are pulled out, so there's a z there left. The 3 is gone. We had 2 copies of x, but we pulled one out, so there's a single copy left. The y has been pulled out front. And we pulled out a 3 from the 6, so there's a 2 there. The x and y are pulled out, and then there's a z squared remaining. So that's that one. Now for number 9, let me just get a little bit more room here. So 16 p squared q squared minus 8 p squared q to the 4, 24 p to the 4 q squared. Just give me 1 second. I'm just going to move this up here maybe, and that'll give us a little bit more room. All right. So what can we do here? Well, 16, 8, and 24. We can pull out a 4, but even better, we can pull out an 8. And p squared is our lowest power of p, so we can pull that to the front as a common factor. The quantity out front, this is our common factor. And then this is what's left over. And then the q, we have a q squared left there. Our q squared is common. So let's see what is left over after we pull that to the front. There's going to be a 2 here. 8 times 2 is 16. P squared and q squared have both been factored out, so there's nothing left there. The 8 has been completely pulled out. P squared as well. But q to the 4, we took out 2 copies of q, so there's a q squared left. And then 3 times 8 is 24. P to the 4, we took out a p squared, and the q squared is gone as well. And there's number 9. So let's now take a look at the next 3. And then that'll finish our little discussion of factoring by grouping. Sorry, factoring common factor. Now, this one here is has a little different flavor, but it is still just common factoring. Why don't I just to warm up here to get the idea for number 10, imagine that instead of x plus y, I just have another letter like a, all right? So I'm going to replace x by y by a in both places there, and I get 3xa minus 4a. Let's say I gave that to you. Based on what we were just doing, I don't think you'll have any problem with that. We could factor out an a, right? So let's do that. If we take out an a, we would be left over with 3x minus 4. That's easy. Now, since a is a monomial, I don't need to put brackets on, but I could. And just as this one is easy, this is the same thing. The only difference is instead of a little a as a single variable, we have x plus y. So just as we pulled out a here, we can pull out x plus y here. So that's the idea. So for number 10 here, we look at, there's 2 terms here. This is the first term. This is the second term. And they're separated by a minus sign. And we can identify that x plus y is common, just as a was common here. And we can factor that to the front. You know, here I didn't need to put brackets around the a, but here I really do need to put brackets around the x plus y. And then just as over here I had 3x minus 4 left over, same thing over here. You know, if I didn't write these brackets here, this would be wrong. We really do need to write those brackets. Okay. So that's the idea there. So same thing for 11 and 12 here. So if we just imagine, instead of a minus b, which is kind of bulky and big, just imagine that's a single letter like C or something, okay? When I give you this is the same thing as this. I just made this, imagine this is C, a single letter. When I give you this, I'm sure you have no problem identifying that C is common, and you can pull that out. And same thing here. We can pull out a minus b to the front, just as we pulled out c here. And what do we get? Well, a minus b is common. We pull that to the front. And then we get 2a plus 5b. And the brackets are optional here. I don't really need to write them here, but here they're mandatory. I have to. Sometimes I see students, they write the 2a plus 5b first, and then the a minus b. I kind of find that awkward because we're pulling out a minus b to the front. So I kind of want to write that in the front. So even though technically it doesn't matter the order, right? I still think it's more natural to pull it to the front. So here, same thing, the p plus 5 is common. So if you want, you could maybe imagine that the p plus 5 is just like the letter q or something. So we have 3pq minus 7q. We can factor that q to the front. Or in other words, we can factor the p plus 5 to the front. And then we get 3p minus 7. All right, so that takes care of common factoring. That's our little review of common factoring. And now let's move on to the next kind, which is what we're going to call grouping. This is the second page here. Let's grab these first 4 questions. So grouping, like I mentioned, it's going to have 4 terms. Notice all these have 4 terms. And let's see how these go. So this is a different style of factoring. Notice there's nothing common here. Like if you look at all of these, there's no number that divides into all of them. 4 goes into these 2 guys, but 4 does not go into those terms. A is in here and here, but not there and there. Y is in these guys, but not those. So common factoring does us no good on this one. We really do need a different kind of factoring. And this is our second style of factoring we mentioned, which is grouping. So the style of grouping, or the technique of grouping, is we look at these in pairs, okay? So we look at the first 2 terms and then the second 2 terms. Since we said that there's going to be 4 terms in grouping, we can think of this in 2 pairs with two each. And then we really just do common factoring on each of these separately. Like if you look at this first one, just focus on these first 2 terms. What's common there? It's a, right? So let's pull out an a. And then we get y plus, what goes there? We took out the a, so we need a 1 there, right? Not a 0, or don't leave it empty. If a times y is a times 1 is a. And one thing about grouping, whatever sign is here, that sign is going to be here as well. So if there's a plus sign here, there's going to be a plus sign there. If there's a minus sign there, there's going to be a minus sign there. And what's common in with these 2 guys, just focusing on these 2, what's common there is a 4. So let's pull out the 4. And then we get y plus 1. So to do grouping, we use the technique of common factoring, but just on these 2, on this pair, and then on this pair. And notice that these are the same now. This is why we did this previous question up here to warm up for grouping. See, this y plus 1 is common now, and we can pull that to the front as a common factoring. So grouping uses common factoring, and then a plus 4 is what's left over. Again, a lot of times here I see students, they write a plus 4 first and then the y plus 1. And I kind of find that awkward. Since y plus 1 is common, we're pulling that out. So I think that should be at the front. You know, like let's say this was ab plus 4b or something. And I ask you to factor that, you would use common factoring, and you'd pull out the b to the front, and you would write a plus 4. And that's the exact same thing here, except instead of b, we have y plus 1. Over here, you wouldn't really write a plus 4 times b, right? That's not natural, even though technically it's correct. So, oh, I shouldn't have erased that. All right, so that's our answer for that one. Okay, number 2. So again, we're going to look at these in pairs. We got those two and then those two. So what's common here? X squared. Let's pull that out. And then I have x plus 2 left. We have a plus sign here, so there's a plus sign here. What's common with 3x plus 6 is the 3. And then we get x plus 2. And since these are the same, that means that can be factored to the front as a common factor. And then we get x plus 2 times x squared plus 3. And that's our answer. So notice factoring, notice that our final answer is written as a product. It's been factored. And that's what the goal of factoring is. Number 3 here. I'm noticing we have a minus sign here. But again, we just look at these in pairs. You know, I see sometimes students, they write brackets here. This is dangerous because when you write brackets here, you've actually changed the expression, because if you were to multiply out the brackets again, you get minus 3xy minus 21y squared. But the question is not minus 21y squared, it's plus 21y squared. So I don't write brackets there. I just kind of underline it here. Maybe even later on, don't even write nothing under there. Just leave it blank. Just think to yourself that you're looking at these two pairs here. So let's factor out whatever is common on this first pair. I think that would be an x squared. And then I'd have x minus 7y left. There's a minus here, so there's a minus there. 3 and 21, I can pull out a 3. And there's a y common, so I can pull out a 3y. Now, you know, this is just a minor comment, but for this to work out, you need x minus 7y here, okay? Don't just write it there. Don't just write x minus 7y. Actually don't look at this and just factor this. And then afterwards, look and see to make sure they're the same, eh? So when I pull out a minus 3x here, I have a y left over. Since this is a plus and I pull out a minus, I know that has to be a minus. 21 divided by 3 is 7. I pulled out a single copy of y, so there's a y left. Sorry, I made a mistake. It should be x, right? 3y times x is 3yx, which is the same as 3xy. And then minus 21 divided by 3 is 7. We've pulled out one copy of y, so there's a single y left. And again, these are the same. Now I look, I say, oh, these are the same. That means everything is going good. And we can pull that we can factor that now. So let's factor out the x minus 7y to the front. And then x squared minus 3y. And that's good. I guess I'm running out of room here. Maybe I'll just do number 4 up here. It's kind of out of order, but maybe I'll just, give me 1 second. Just move this here. Move these guys. My computer is, there we go. All right, so number 4. Let's see what we have here. Let's look at these in pairs. How about we not even write it this time? We just think it. So we look at these two guys and we factor out what's common. That would just be the x, right? And then we get y plus 3z. And then we factor out here the 2z. And 2z is gone, so there's a y left. And then we have a 3z there. And then I notice these are the same. That means everything is good, and we can factor that to the front as a common factor. So these are the answers. Okay, so that's giving us some feeling of grouping. Let's look at 4 more, and then we'll move on to the next kind of factoring. Let me just check something here. Yeah, okay. So here's the next kind, or the next four. So number 5 here, what do we got? So on this first pair, we can factor out a 3x. Notice there's nothing in common everywhere, right? Oh, I'm sorry, I'm wrong. I forgot to read the directions. Remember to look for a common factor first. There's actually a common factor here that we could pull out first. Now, this brings me back to, I want to go back to the very first page here, and I want to make an important comment. Is whenever you do any of these kinds of factoring, you should always try to do this one first, okay? You know, on harder factoring problems, you won't just do one kind of factoring. You might do 2 or even 3 types. And the very first thing you should look for is a common factor. So before I try to do grouping on pairs here, I look for a common factor. On these ones up here, there was no common factor on any of them. So that didn't apply. But on these ones, these all have a common factor that we should pull that out first and then do grouping on what's left over. So let's look at this and see what's common. I think 3 is, all these coefficients are divisible by 3. And, oh, I'm sorry, we don't have an x there. So I think some of these will have a common factor, but some won't. So actually 3 is common. So even though x is not common everywhere, we still want to pull out the 3. So that's our very first step here. So let's take out a 3, basically divide all these coefficients by 3. And now the thing in the brackets is what we're going to do grouping on, okay? And we're going to look at these in pairs. Now it's no big deal, but we're going to have a double set of brackets here. You don't have to do this, but I think I'm going to use square brackets, okay? Just to make the brackets look different. Okay, so let's see. So 3. So what's common here that we can, so now we're doing grouping on the thing inside the brackets. We first did a common factor of 3, and then we're going to do grouping here. And we look at what's common there. That's an x. X times x minus 4. What's common there is a y. And then we get x minus 4. And then x minus 4 is the same, so we can pull that to the front. And you know what? I'm going to, how about, okay, I could keep writing those square brackets there. But at this point, the square brackets aren't really doing anything. So how about I not write those anymore? I wrote them up here to make things clear. But when I get to this stage, which is the final answer, I don't really need them anymore. Okay, good. So let's try the next one here. So we have to keep our eyes open for the possibility of a common factor here. Definitely 2 is common, right? And y is common as well, but not x. X is present in 3 of them, but not the last one. So here we can pull out as a common factor as our very first step. We're going to pull out a common factor of 2x. And then I'm going to use square brackets. I could use round brackets too, but square brackets makes it a little bit easier to read. And then I have xy minus y minus y squared plus y squared. No. Sorry. You know what? We don't pull out a 2x, we pull out a 2y, right? So let's see what we get. We get 2x squared, sorry, x squared. And we pull out a 2y here, so there's just an x left. Here we pull out a 2y, so it's xy. And then here we have a single copy of y left. All right. So, oh, I didn't write square brackets. How about I just write curled brackets? And then you can see which one you like better, and you can choose whichever you prefer. So we're going to look at these in pairs, right? We're doing grouping now. What's common here is an x. Let's factor that out. We get x times x minus 1. What's common here? Notice there's a minus here, so we're definitely going to have a minus there. Y is common, so pull out a y. And then we get x minus 1. These are the same, so we can pull out the x minus 1 now. Notice how when you write curled brackets on both of these, it kind of maybe looks a little more confusing, or I think it's a little bit more clear to look at this than that, but it's not a big deal when you get used to it. So the 2y, notice the 2y is just sitting out front. It's just coming along for the ride. This is our main thing that we're working on after the first step, and we're doing grouping on that. We see the x minus 1 common there. We can pull that to the front. And then x minus y is here. So here we have 3 factors in our answer. Whereas in the other things we saw today, there's just 2 factors in the answer. So when you do factoring, you can expect multiple factors. All right, so I'm out of room on this page, so I'm just going to go to a new page. So let's factor number 7 here. Again, always try to do common factor first, and I think there is a common factor here. At least, certainly we can pull out a 4. And I think that's it, though. And notice since there's a negative here, we should pull out a negative 4. Whenever you lead with a negative and you do factoring, you pull out a negative as well. So let's pull out a negative 4. How about I use square brackets here? What do I have left over? X squared minus 2xy. Since I have a minus 20 and I'm pulling on a minus 4, negative 20 divided by negative 4 is a positive 5x. Positive 40 divided by negative 4 is a minus 10y. All right. And now we're doing grouping on these 4 terms in here. We did a common factor first, and now we're going to grouping. And we're looking at this pair and this pair. What's common on these 2 guys is an x. Let's pull out the x. We get x minus 2y. What's common here is 5, positive 5. There's a plus here, so there's a plus there. X minus 2y. We see that these 2 are the same, so we're happy about that. That means that's common. Imagine this is like the letter Z or something, right? Like if you had XZ plus 5Z, you could pull out the Z. And that's all we're going to do here. We're going to pull out the x minus 2y as a common factor. So, and at this stage, I'm going to drop the square bracket. So I have minus 4 here. I'm pulling out the x minus 2y. And then I have x plus 5 left there. And there's our fully factored answer. All right, number 8. Let's take a look at this one. We definitely have a common factor here. Between the coefficients, 5 is our greatest common factor. X is present in these 3, but not that one. Y is present in these last 3 terms, but not the first term. So we can't pull out a variable, but we can pull out a 5. So let's do that. So we get 12x squared minus 6xy plus 2xy squared minus y cubed. Oh, I forgot to write square brackets, so that's okay. So what's common on this pair is a 6x. And then I have 2x minus y. There's a plus here, so there's a plus there. What's common here is y squared. And then I get 2x minus y. I notice these are the same, so I'm happy about that. That means I can factor that to the front. And then this set of outer brackets, so I'm going to drop them now. The 2x minus y comes there as a common factor being pulled to the front. And then this 6x plus y squared is what's left over. And there's our fully factored answer. Okay. So that takes care of our discussion of grouping. And now we're moving on to trinomial factoring. So this one's pretty important. Here's the first set. Maybe before I go to that, I'm just going to write down something about trinomial factoring. So this is another kind of factoring. This is not common factoring, and this is not grouping. This is yet another technique. And so a trinomial, it looks like this, eh? Ax plus bx plus c. Tri, of course, means 3. There's 3 terms here. And you need to make progress on factoring this. We need to do something. We need to solve a little problem, and we need to find 2 numbers which have a sum of the b value, and the 2 numbers also at the same time have to have a product equal to a times c. So this is a very key thing to remember. I'll explain what I mean by this in a second, but this is going to be a key thing that's going to come up a lot. So let's see what I'm talking about here. So for the very first problem there, we have x squared plus 8x plus 15. And I would like you to think of what are the values of A, B, and C for this. So, you know, sometimes when I ask like a student, what is the value of B, they'll say 8x, but we don't want to put the x on there. It's just the number in front of x. So B is 8, okay? The C is 15, positive 15 or just 15. And the A, maybe it looks like there's nothing there, but there's really a 1 there, eh? So A is 1. So A, B, and C are this. So according to this little problem that we got to figure out, the sum has to be the B value, which is 8. So, and the product is whatever A multiplied by C is. In that case, it's 1 times 15, which is 15. So you need to think about this. We have to find 2 numbers that multiply to 8. Sorry, they have to add up to 8. That's what sum means. And product is multiply, right? They have to multiply to 15 and add up to 8. So that's pretty easy, right? 3 and 5. Now, if you, let's say somebody else would have wrote 5 and 3, that'd be okay too. The order doesn't matter, right? Whatever order you want to put them in, that's perfectly fine. So let's think of the 3 and the 5 here. These are our magic numbers. And that's the key to factoring this. And notice since A is equal to 1 here, this is what I called the easy case. Remember at the beginning here, how I said when A is equal to 1, this is the easy one? So, and this is there's a shortcut method here that allows us to factor this basically instantly. Once you get these 2 nice numbers, once you solve your sum product problem, you actually can factor this right away. It's imagine there's x's on the end here. So instead of 3 and 5, imagine like 3x and 5x. And I take that back. There's 3 and 5 here, so this is just x plus 3. Imagine there's a plus sign in front, right? And x plus 5, and that's it. So you identify A, B, and C. You solve your sum product problem. You find your two nice numbers here, and then you're done. And that's because a is equal to 1. Later on, we're going to do a couple examples where a is not equal to 1, and then this won't be, we'll have more work to do. And you can always check your answer. I haven't been doing that so far, but just to check your answer, let's take what I wrote down here and let's multiply it out and see if we get back to what we had. Now, some people call this FOIL, right? When you multiply across like this, these two are called F for first term. These are the outer terms, the ones on the edges. These are the inner terms, and then this is the last term. I don't really even think about FOIL. I just think that this first term has to hit both of those, and then this term has to hit both of those. And if we do that, I'm going to get rid of this FOIL. I don't really like FOIL. It doesn't matter. But so start with x. X times x is x squared. X times 5, x times plus 5 is plus 5x. And then move on to the next term, which is plus 3. And now take 3 and multiply it to both of these. 3 times x is 3x. 3 times 5 is 15. And then notice these are like terms. Those could be blended together. 5x plus 3x is 8x. And look at that. We get back to the original question. So that's the goal of factoring, right? You write this as a product. And if you multiply this out, you get back to where you started. I should have maybe mentioned that in some of these other examples. Like if you multiply any of these back out, you get back to where you started, right? That's how you can check it. I haven't been doing any checks here, but you can always do a check if you feel like it. All right. I'll leave the check there, even though it wasn't asked for. But just understand that this is the answer right here, though, okay? This is what's going to get you your marks. Okay, number 2. So, when I defined a trinomial here, I used the variable x, but you can use any letter. Here it's n, here it's m. So the letter used for your trinomial doesn't matter. Very often it's x, but. All right, so let's identify a, b, and c. Now, later on when you get good, you don't have to write this. It's just since we're practicing here, we're learning it for the first time, I'll write down what a, b, and c are. But later on, you can just really do that in your head. So a is a hidden 1, so a is 1. Sometimes when I ask students what b is, they'll say 8 here, okay? But that's not good enough. It's really a minus 8. This is kind of playing the role of a subtraction sign and a negative sign. And then this is negative 9. So our sum product problem here, the sum has to be the b value, negative 8. And the product has to be whatever a multiplied by c is. Since a is 1, it's in this particular case, it's really just what c is. But don't get used to that. It's later on when a is not equal to 1, the value of a really matters when we do this a times c. But for right now, we can kind of ignore the a. But I think it's a good habit just to remember the product is always not just c, but a times c. So we got to think about this now. We got to multiply to negative 9 and add up to negative 8. Don't think of ways to add up to negative 8. There's like infinitely many ways of doing that. Think of ways to multiply to negative 9. And even just as a starting, just think of ways to multiply to 9. There's only really 2 ways to multiply to 9, 1 times 9 and 3 times 3, right? Using 3 and 3, there's no way we could ever get an 8. So it has to be 1 and 9. Or 9 and 1, whatever you feel like. And you notice since we're multiplying to a negative, one of these guys has to be negative and one has to be positive. That's the only way to multiply to a negative. And it really doesn't matter which one you put the negative sign on. If we put it here, the product would be fine. Negative 1 times 9 is negative 9. But when I add those up, I would get positive 8. And I don't want positive 8. So the negative has to go there. Now, maybe you would have written negative 9 and 1. That would be okay too. It's up to you. Just as long as you have these two numbers here, the order doesn't matter. Now, since A is 1 here, the shortcut method is available. We can go straight to the answer. We're going to write the brackets for the factored form. The variable just goes here. And then these numbers go in these empty spaces here. The -9, I'll put right there. And this is really, there's no plus written in front of that, but you should think of this as a +1. So +1. And that's factored. If you multiply that out, you will get back to the original expression. All right, so I'm out of room there, so I'm just going to go to a new page. So let's take a look at number 3. Let's identify A, B, and C. Later on, we'll stop doing this, but just since we're starting out, let's get in the habit of that. So A is a hidden 1. That means the easy shortcut method is available. What I mean by the shortcut method is once you know these two numbers, you can go straight to the answer, okay? Later on, when A is not equal to 1, like if we look a little bit further in the document here, you see on this next set, the next questions we're doing, A is not equal to 1 here. So the shortcut method will not be available to us. We're still going to find two numbers which have a sum of B and a product of A times C. But after that, I have to show you something to how to do it. Okay, so B here is +6 or just 6, and C is not 16, it's -16. And now let's find the two numbers that we want. Sometimes people just write S and P instead of sum product. It's up to you. I'll just write the full words out. So the sum needs to be B, and the product is A multiplied by C. 1 times -16 is -16. So we got to think about that now. Ways to multiply to 16. Well, we got 1 times 16, 2 times 8, and 4 times 4. How could we get 6? I don't think we could get 6 with 1 and 16, and I don't think we could get 6 with 4 and 4. I think it would have to be 2 and 8. And since we're multiplying to a negative, one of these guys is negative and one is positive. And I think the only way to achieve that would be to put the negative here. If we put the negative on the 8, it would add up to -6, and we don't want that. So we have our two, think of, when you do trinomial factoring, think the key is to get these two numbers, okay? Once you get these two numbers, you're in good shape. And when A is equal to 1 here, you're in really good shape because you're going to be done. It's going to be x minus 2 and then x plus 8. All right, number 4. This will be the last one that's easy, the A equals 1 case, and then we're going to move on to the A not equal to 1 case, which is maybe the trickiest stuff we'll talk about today. But it's not bad. Okay, let's identify A, B, and C. How about we don't even identify A, B, and C? Let's just go to sum and product right away. We know what A, B, and C are. A is 1, B is -6, and C is 9. So the sum needs to be B, right? So the sum needs to be -6. And the product is A times C. 1 times 9 is 9. So the only ways to multiply to 9 is 9 times 1 and 3 times 3. There's no way to get a 6 with 1 and 9, so we have to use 3 and 3. Notice that the product is positive. That means both numbers are positive or both are negative. And since we want a sum to be negative, I think there's no other choice that both of them be negative. And that actually works. So let's get the answer in one step now. Once we found our two nice numbers here, we get m minus 3 and then another m minus 3. Since this is repeated, both of these factors are going to be the same. And you could stop there, or you could write this. Since they're both the same, you could write this like this, say, m minus 3 squared. Okay, so that's the easy style for trinomial factoring. Now, let's take a look at the case where a is not equal to 1. This is still trinomial factoring, but it's just a little bit harder because the a is not equal to 1 here. Once we get those two numbers, after we solve the sum product problem, we have more work ahead of us. We can't just go straight to the answer. So for number 5 here, we know what a, b, and c are, right? A is 2, b is 5, c is 3. So our sum needs to be b, which is 5, positive 5. And our product, a lot of students, they get in a bad habit when they do these ones because they just think the c value, the product number is always the c, but it's not true. The product is a times c, and here it really matters. We do not want to write a 3 here. We want to write 2 times 3, which is 6. And then coincidentally, the two numbers that work here are obviously 2 and 3. So the mistake now would be to apply the a equals 1 situation where we would just write x plus 2 and x plus 3. This is no good. If you FOIL that out, x times x is x squared, but we want 2x squared. So this is where we got to do a little bit more work. And we're actually going to do grouping here. So here's what we do. The reason we call this the decomposition method is because we're going to decompose this into two pieces. Imagine there's like x's on here. So this is like 2x and 3x. So we're going to replace plus 5x by plus 2x plus 3x. That's the same thing. So we're allowed to do that. You may wonder why are we doing that, but you'll see that it works. These two guys on the ends, they're just going to be recopied, okay? So we decompose the middle term using these two nice numbers we found here when we solved our sum product problem. And now we use grouping. That's why we learn grouping basically is to help us with these trinomials. So we're going to look at this pair and we're going to look at this pair. So we're using grouping here. So when we do the decomposition method, trinomial when a is not equal to 1, grouping is going to be a key step. After we decompose this guy, the 3-term expression now becomes a 4-term expression, and we can use grouping. So what's common on the first pair? 2x, right? So let's pull that out. We have x plus 2 left. What's common here is a plus 3. Sorry, I made a mistake. When I pull out a 2x from there, I just have a 1 left. And here I pull out a 3, and I have an x plus 1 there. I knew I made a mistake because let me go back to what I can't remember. I think I had x plus 2 here, and then I pull out a 3 here. And I knew I had a problem because if these are not the same, things are wrong. If you get these two numbers right, then these two guys better match. But I just made a silly mistake there because when I pull out a 2x, I get a 1. And then I pull out a 3 here and I get x plus 1. And these guys match. Those are the same. Remember back here when we did grouping? Wherever it was, right here. This is the style of what we're doing exactly right now, kind of. We're pulling out the x plus 1 here. And we get 2x plus 3. And that's it. That's our answer. All right, number 6. So we see that when the a is not equal to 1, we have a little bit more work because we have to write down a few more lines here. So let's think about the sum and product for this particular one. Notice there's nothing common here, so we can't use common factoring. And it doesn't have 4 terms, so we can't use grouping. We need this new style of factoring, which we're calling trinomial. So the sum is the b value, which is plus 16. What is our product? It's a times c, which is negative 18. 6 times negative 3 is negative 18. So to multiply to 18, we got 1 times 18, 2 times 9, 3 and 6. I think the only way to get 17 is with 1 and 18. Since we're multiplying to a negative, I know 1 is negative, 1 is positive. In order to get the plus 17 when I add them, I'm going to have to put the negative here. And again, do not do this. Do not write x minus 1, x plus 18. That's only available when a is 1, and a is not 1 here. So we have to use the decomposition method. We got to break this middle term up into two pieces using these two numbers here. So the 17x, let's break it up into minus x. You could write a 1 there, but usually we don't. Minus 1x is just minus x. So, and then plus 18x. And then the minus 3 is recopied, and the 6x squared is recopied. And now we're doing grouping. Maybe I'll put an arrow here as well. So let's see, on this pair, we can factor out an x, right? 6x minus 1. Here we can pull out a 3. What's left over? And 6x minus 1. These are the same. That means everything is good. Let's factor out the common 6x minus 1 now. And then we get x plus 3. Okay, that looks good. I guess for 7 and 8, I'll just go to a new page. So what we got here. So our sum is going to be the b value, which is 8. And our product number is going to be 3 times 4, which is 12. And I think that's 6 and 2, right? Or 2 and 6, whatever you feel like. So notice we got 12 by doing 3 times 4, but the numbers we're using here are 6 and 2. So just because we multiply 3 times 4 to get 12, it doesn't mean 3 and 4 are the numbers. It could be, but it's in this case, it's not. So 6 and 2 are the nice numbers. And we're going to break this middle term up into 6x plus 2x. And then the other terms are just recopied there. Whoops. So the 3x squared at the, you know, this 6x has a plus, right? So we need to write, we don't want to write, we can't just write 3x squared in front of that, right? With nothing there. We need to write a plus sign there. And the plus 4 is sitting there. And then we're going to use grouping now. So we're going to look at this pair, factor out the 3x. We get x plus 2 there. And then take the 2 out, and we get x plus 2. And then these are common. Pull that to the front. That's how grouping goes. And we get our answer. All right. So that's number 7. And let's do number 8 quickly. Looks like we got a negative sign in here. So what's our sum and product for this one? Our sum is our b value, which is negative 5. Not 5, right? Negative 5. Our product is 6 times negative 1, which is negative 6. And what are the numbers here? I guess negative 6 and 1, right? So let's decompose. Remember back here, we broke that up using these two numbers. Just imagine there's x's on these. Same thing here. Imagine there's x's on those. So this is going to become negative 6x. You have to write a plus there. There's a hidden plus sign there. So plus 1x. But we don't need to write the 1 in front of the x. We're just going to write x. And then these two guys on the ends are recopied. And now we have 4 terms, and we're going to use grouping. Look at this first pair. Take out a 6x. Get x minus 1. Now, we haven't encountered this today, I don't think. There's nothing to take out here. And when that happens, you take out a 1. So let's pull out a 1. You can always pull out a 1. It's kind of seems like you're not achieving anything there, but it's a good thing to do in this particular case. Oh, I just noticed there's comments here. Sorry about not looking at that. Let me hopefully everything's making sense. Do I also use that for an A isn't 1? I think maybe that was, you mentioned that when we were doing these ones back here, but would you ever do calculus? Absolutely. We're going to do calculus lectures as well. Yeah, some people do it a different way. Absolutely. There's a good video. I think it's called Blue Pen, Red Pen, and he describes the different ways of doing it. And there's definitely another style of doing it, but it's more guessing. This is kind of, I like this way because it's systematic, but there is another way to do it. And it's a little bit more guessing and testing. Whereas this is, you just follow this method and you get the answer. The disadvantage of this one, there's more writing. If you kind of just do it at this other method, it's less writing. You can pretty much do it in one step, but you got to do some different testing of, like when you multiply to 4, you could do 2 times 2 or 4 times 1. With 6x squared, you could do 2x times 3x. Or 3x times 2x, 1x times 6x, or 6x times x. So just for this little lecture here, I'm just presenting this technique here. But maybe I'll show some other techniques later. All right, so notice the x minus 1 is common there. So let's factor that out. And we get x minus 1 times 6x plus 1 for number 8. All right. So let's move on to more trinomial. But these trinomials now, they have 2 variables in it, okay? But it's no different. Maybe it looks a little bit different at the beginning, but we'll see that it's the same style. Okay. So for number 9 here, notice the A is not equal to 1, so we need to use our sum product technique here. How about I just write S and P? S for sum, P for product. S is -7. The P is 2 times -15, which is -30. And that would be 3 and 10, right? And I would need to make my 10 negative. And now I'm going to decompose this middle one using these 2 numbers. Now, before when I decomposed, I just had a single letter there. But now I have mn. So I need to write 3mn plus 3mn minus 10mn. And then minus 15m squared. So whenever you use the decomposition method, these guys on the ends, they're just recopied. They're the same as what they were, but this one gets broken into 2 pieces using these 2 nice numbers. And then we use grouping. What's common here? Nothing common between 2 and 3, but we can pull out an n. And then we get 2n plus 3. Sorry, 2n plus 3m. There's a minus sign here, so I know there's a minus sign there. And I can take out a 5m. And then I get 2n plus 3m. And like, I notice now that these are the same, okay? I don't just recopy this here. Like I look, I kind of hide this in my eyes and I just focus on this and I do this factoring and then I look and make sure they're the same. And now let's factor 2n plus 3n m out as a common factor. And we're done. Whoops, need a bracket there. So you see that when there's two variables, it's the same idea, right? Let's try number 10 here. Now, I'm not going to be talking about this today, but I identify this right away as a perfect square trinomial. This one is going to be like this at the end of the day. How do I know that? It's because this is a perfect square, right? What's the square root of that? It's 3a. And this is a perfect square as well. This is 2b. And if I do this times 2, I get that term, eh? 3a times 2b is 6ab. 6ab times 2 is 12ab. So I know that this is going to become this. This will be our answer, okay? I'm not talking about this today, but there is a way, I really just explained it right now, how to tell if something's a perfect square trinomial. This one's not, obviously. You can't do the square root of 2 or the square root of 15. But the square root of 9 is nice. It's 3. And the square root of 4 is nice. It's 2. And 3 times 2 is 12. But let's just follow the way we've been doing here. So the sum is 12, which is our b value. Now, don't get confused. I'm using the variable b here and a. But when I say a, b, and c, I mean something else. I mean these coefficient numbers, okay? So the sum is b, which is 12. And the product is the a times the c. And that 9 times 4 is 36. All right, what about this one? I think that's 6 and 6, right? 6 times 6 is 36, and 6 plus 6 is 12. So let's decompose this middle term using 6ab plus another 6ab. And I need a plus sign in front of that too. And then, like I was saying, these guys here just get recopied. And now let's do grouping. How about I not even write that? It looks messy. What can I factor out here is a 3a. And then I get 3a plus 2b. What can I factor out here? A 2b. And I get 3a plus 2b. And then I notice these are the same. So let's pull that 3a plus 2b to the front. And then the other term is, again, 3a plus 2b. And like we were noticing at the beginning there, that can be, you can leave it like that, but maybe it looks a little bit nicer to write it like this. So there's our answer for that one. So this is the answer for number 9. This will be our final answer for number 10. For 11 and 12, let me go to a new sheet. So again, we have two variables, but it's no different. Don't be intimidated when there's two variables like that. We're just going to solve the sum and product again. Sum is negative 14. And the product, 8 times 3 is 24. What's going to work here? Well, you know, there's quite a few ways to multiply to 24. You got 24, 1 times 24, 2 times 12, 3 times 8, 4 times 6. And that's all. And I think that the only way to get 14 is with the 2 and the 12. And I think they both have to be negative. So those are the nice numbers. That's going to be the key to solve this. Getting these two numbers, that's the key to factoring, okay? And the order doesn't matter. If maybe you wrote it down negative 2, negative 12, and negative 2, that would work fine as well. Don't be concerned about the order. But the signs are important. Like, Sometimes when one is negative and one is positive, the negative, where the negative goes, that's critical. If you put the negative on the 3 here, it wouldn't work. All right, so let's break this up. So this is minus 2ab minus 12ab. This guy gets recopied. And so does this. And then we're going to use grouping on this 4-term expression. What's common on this pair is a 2a. We get 4a minus b. What's common here? Notice there's a minus, so we need a minus here. And the 3 is common, and so is a b. And then we get 4a minus b. And these are the same. That better be the case, and it is. And we pull that to the front, and then what's left over is the 2a minus 3b. And there's our answer for number 11. You know, if your answer has these factors in the other order, like maybe you have 2a minus 3b in here and 4a minus b. Maybe, I think if you write these in the opposite order, maybe it comes up like that. I can't remember. Or maybe not. But either way, if your answer is like this, that's fine. Because remember, order of multiplication doesn't matter. So as long as you get these two factors, that's great. That's your answer. The order doesn't matter. All right, one more of these kind, and then we'll move on. So our sum product here, our sum is the b value. What's their b value here? It's -1, right? There's when I write that minus sign there, that really means -1. So I'm not going to do that. I'm going to actually write a 1 here, but here I just write a dash. And the product is 15 times -2, which is -30. And I think for this one, 5 and 6 will work. And I need to put the negative on the 6. So imagine, instead of 5 and -6, imagine it's 5 PQ and minus 6 PQ. Positive 5 PQ minus 6 PQ. This is called the decomposition method. And the reason for that, of course, is because we just decompose that middle term. This stays still, recopied. This is recopied. And then we look at these in pairs and we do grouping. Just focus on these two guys. What's common there? 5p. And we get 3p plus q. What's common here is a minus 2q. And then 3p minus plus q. And 3p plus q is common. Let's factor that to the front as a common factor. What's left over then? 5p minus 2q. All right. So that's number 12. All right. So what's the next one we're going to look at here? So that was number 12. So we're just going to do trinomials where we remember that we should always be looking for common factor first, okay? Each one of these is going to be common factor as the very first thing we do, and then trinomial after that. On all of these, there was no common factor, okay? On all these ones we've been doing. So that didn't come up, but these guys, each one is going to have a common factor, and we're going to pull that out as our first step, and then we're going to do our trinomial stuff. So for number 13 here, you when you do factoring, you have to train yourself to always, before you start a factoring, you should always ask yourself, is there a common factor? And then you pull that out, you look at what's left over, and then you say, maybe I can factor what's left over even more. So on this one, 6 does not go into 33 or 45, but 3 does. 3 goes into all of these. So we can pull out a 3. And we can even pull out an x. So let's pull out a 3x as the very first thing. And then we get 2x squared plus 11x plus 15, right? And now we're going to do trinomial on what's in the brackets here. So we're going to factor this guy using the trinomial factoring. So we first do common factor, and then we get a trinomial that we can work on. And let's do our sum product on this one. You know, this 3x here, it's not really going to play a role in the rest of the problem. It's just going to be recopied. Every line is going to have a 3x in front. And our main work now is going to be inside the brackets here. So the sum should be 11. And the product should be 2 times 5, which is 30. Let's think about what numbers make that work. I think that's 5 and 6, right? And so we're going to break this guy up using 5 and 6. So instead of 11x, we're going to write 5x plus 6x. And this 5x is not just 5, but it's a plus 5. The plus 15 is recopied. And the 2x squared is recopied. And you know what? I think square brackets would be nice here. I think it's kind of nice to have the distinction between the square brackets and then the normal curled brackets when we do grouping. It's a little bit less confusing. So we're doing grouping now, right? What's common on this first pair is an x. What's common here is a 3. And now these are the same. Good. So I can pull that out. And then at this stage, I kind of drop my square brackets and I write my 2x plus 5 that I'm pulling out. And then what's left over is the x plus 3. All right. So that's done. Let's look at 14. So I guess by the instructions, we kind of know that we should look for a common factor. In a normal question, they won't even tell you that. You have to know to do that yourself. So what's common here? I think 6, right? 6 is common there. But no letters. Here we could pull out an x, but not here. X is present in these two, but not that one. Y is present in these two, but not that one. So let's pull out a 6. And then we get 4x squared. What's 72 divided by 4? I should know that. 72 divided by 4. This is kind of silly. Let's use little kids division here. 4 goes into 7 once. And then 3, and bring that down. 4 times 8, right? So 4, we got an 18 there. 6 times 18 is 72. XY. And 6 times 9 is 54. Okay. Now, just by experience, I can tell this is a perfect square, right? What's the square root of that? It's 2x. What's the square root of this? It's 3y. If I do this times 2, let's see what happens. 2x times 3y, that's 6xy times 2. Sorry, I made a mistake there. What's 672? Oh yeah, what am I doing? It's 12, of course. I should know that. It's embarrassing. So let me correct that. That's 12. What is 2x times 3y times 2? Yeah, you just have to multiply by that 2. This times this is 6xy times 2 is 12xy. So I know that this is a perfect square, and it uses 2x and 3y with a minus sign. So how about we save a little bit of time by just going straight to that answer? You definitely can use sum and product here as well. So you could, if you did it by sum and product, you would get the same thing at the end of the day. But if you can identify this is a perfect square, you'll save yourself some time. All right, so I'm cheating a little bit there by using, by identifying this as a perfect square, but it's good to know that technique. It doesn't happen that often. That's why we kind of forget to look for it. But if you see this is a perfect square, like the 4 is a perfect square, right? And so is 9. You take the root of those guys, you get 2x and 3y. If you multiply them and then times 2, you get 12. You know you're good. And you can go straight to that answer and you can skip this stuff. So that's nice. Let's look at 15 and 16 here. So I noticed on 15 we have a common factor, and we should always pull out a common factor if possible. It's not always possible, but if you can, you should take out a common factor. And I think 10 is common here. So let's pull out a 10. And we get that. And now this is a normal trinomial factoring. The sum needs to be the 7, which is our b value. Again, don't get confused with this b. It's just a coincidence that the variable is b, and then we usually call this number b as well. That's just an unfortunate coincidence. And the product should be 2 times 6, which is 12. And I think 3 and 4 is going to work for that. So we're going to break up this guy into 3b and 4b, plus 3b, plus 4b, and then plus 6. And then there's a 10 here. Again, that 10 is just going to be coming along for the ride. It's going to be recopied every single line. And maybe we'll switch to square brackets. How about not? We'll leave the curled brackets. You can see how it looks. Let's take out whatever's common here, which is a b. So we get 2b plus 3. What's common here? A 2. 2b plus 3. And 2b plus 3 is common. So I don't know how you find that. Maybe you like the square bracket better, or maybe you don't mind the curled bracket. It's up to you. But regardless, we're going to drop these big outer brackets here, and we're just going to write the 2b plus 3 here, and then the b plus 2. And one more, and then we'll be done with trinomial. So for 16, let's take a look. 4x squared y minus 17xy minus 15y. So 4, 17, and 15, there's nothing common there. But y is common. So we're going to pull out a y as our very first thing. We don't want to try to do trinomial factoring on this. It wouldn't work. We got to pull out that y first. So when I do that, what's left over? 4x squared minus 17x minus 15. And now we're going to do trinomial on that. So our sum number is our b value, which is negative 17. And our product is 4 times negative 15, which is negative 60. And there's actually a lot of ways to multiply to negative 60, or to 60. And I think what would work for that? So 60, you have like 1 times 60, 2 times 30, 3 times 10, 4 times 15, 5 times 12. Yeah, that's it right there. You know, sometimes just a little trick. I don't know if you guys you might, I don't know if you're allowed to use a calculator or not, like this, like the TI calculator. But one little thing you can do is this. Go to y equals. And whatever number you're trying to multiply to, let's just ignore the negative. Just say 60 and do 60 divided by x. That's the trick, okay? 60 divided by x. And then look at the table. And start at 1, okay? You see all the ways to multiply to 60, they're kind of right here, eh? I forgot to write 6 times 12. I didn't need it. That's why I stopped there. But 6 times 12, 6 times 10 is also good. But 7 7 doesn't work, right? Because there's a decimal there. So it's kind of convenient to have all the ways to multiply to the number in front of you, and it helps you identify the way to get 17, right? That'd be 5 and 12. Okay. So let's write those down, and I think they both have to be negative, right? And now once we have these numbers, we're in business because we can break up this middle term now, right? I'm going to write square brackets. I think it looks nicer. So minus 5x, minus 12x. I got those from these numbers, and then minus 15. And then I do grouping. What's common here? Just an x. Pull that out. 4x minus 5. What's common here? Notice there's a minus there, so there's a minus there. Pull out a 3. We get 4x minus 5. Sorry. Yeah, 4x minus 5. Oh, we have a little problem with sign here, right? I'm just wondering. Oh, we have a problem here. I have a feeling that I made a mistake in the when I wrote this question down. One thing, if you're ever wondering if something can be factored, you should do what's called a discriminant. And that's b squared minus 4ac. Let's calculate b squared minus 4ac for this one. You know what? 3 and 20 are the numbers, not 5 and 12. That's why we're having a problem here. That's why I'm having a problem. I'm going to back up. We want to use not, with 5 and 12, 5 times 12 is 60 and 5 plus 12 is 17, but we got to think about these negatives here. So it's actually 20 and 3, and the negative is on the 20. So that's why things were not working out there. So let's go and fix this. No big deal. So when we decompose this, we got to use minus 20x and plus 3x. I thought I made a typo in the question, but I think it's okay. So let's pull out a 4x here. And then we get x minus 5. Here we can pull out a plus 3, and we get x minus 5, and we're good. And so our final answer now, the y is sitting out front. Notice the y is just recopied every time, just like here, the 10 was recopied every time. After you pull out the common factor, it doesn't really play a role in the question. You can't forget about it. You have to remember to keep track of it. But, okay, and then the x minus 5, and then the 4x plus 3. And there it is. Okay, so what's next? So the last page here is difference of squares, and then we'll be done for tonight. So this is yet another style of factoring. Notice all of these have 2 terms, eh? This is pretty easy. The hard part's over. And, before I do this, I just want to make sure, I'll just write this down, okay? Difference of squares, it has a little, basically it's a formula. And this is the formula. It's, the word difference means subtraction, right? So if you ever subtract 2 squares, you can factor this instantly. And what is it? It's a minus b times a plus b. And this the difference of squares is based on this formula. If you multiply this out, like if you FOIL it out, you'll see that the right-hand side becomes the left-hand side. Why don't we check that? Let's do a little check here. If I do a minus b times a plus b, let's see what happens. A times a is a squared. A times plus b is plus ab. Okay, so I took care of my a. Now let's multiply the b across. Negative b times a, I could write minus ba, but just to put things in alphabetical order, let's write minus ab. And then minus b times plus b is minus b squared. These guys, they cancel. And so we get a squared minus b squared, which is what the formula is. So that's just a little proof that the formula is true. Okay, so how do we actually use this formula to factor things? Let's take a look. So 1 is a square. 1 is a perfect square because it has a nice square root. The square root of 1 is 1. What is the square root of 4x squared? Like, what do you square to get 4x squared? That'd be 2x, right? And once you know those two quantities, you can go straight to the answer. The 2x goes here. The 1 goes here. And one of them has a plus and one has a minus. You know, the way I wrote the formula here, I put the minus first and then the plus. But it could go the other way. You could write a plus b times a minus b. I think subconsciously sometimes I write it like this, but sometimes I write it the other way. I'm not even aware which one I do. So if I write a plus b first and then the a minus b, that's perfectly fine as well. So minus and plus. 1 is minus, 1 is plus, and you're done. What about number 2 here? What do you square to get 25? 5, right? The square root of 25 is 5. What about this one? What do you square to get 64d squared? Well, the square root of 64 is 8, and the square root of d squared is d. So it's 8d. So the two key things here are 8d and 5. So it's going to be 8d minus 5 and 8d plus 5. Easy as that. Or you could do 8d plus 5 and then 8d minus 5. That'd be perfectly fine as well. Now, the order matters, though. You can't write the 5 first and then the 8d. Since this d 64d squared was first, the 8d has to be first here, eh? And the 25 was second, so the 5 needs to be second here. This one here is really the same as number 1. It's just kind of the 1, instead of having the 1 on this side, the 1 is here now. The square root of 1 is 1. The square root of 49x squared is 7x. So the key things here are 1 and 7x. So 1 minus 7x, 1 plus 7x. How about this one? You know, it's really important that there's a subtraction sign here. If this was plus, you couldn't do it. You can't factor a sum of squares. So it's critical that there's a minus sign here. There's no formula for a sum of squares, just difference of squares. All right. What's the square root of this first one? 4t. What's the square root of 121? It's 11, right? 11 times 11 is 121. So this is 4t minus 11 and 4t plus 11. And that's as easy as that. All right. Take a look at the next 4. So these ones have 2 variables in it, but it's the same thing. Let's take a look. So first of all, remember, we should always look for common factor first. There is no common factor here. 25 and 36, the only factor that's common is 1, which means there is no common factor. And there's no variable like x or y that's in both. So we cannot use common factor here. In the next set of 4, which will be the last 4 we do today, there will be a common factor, but not on these ones. So what is the square root of this? 5x. What's the square root of this? 6y. So 5x minus 6y, 5x plus 6y. Or the other way, up to you. 100u squared minus 81v squared. Real easy. The square root of this is 10u. So I know 10u goes first on both of these. The square root of this is 9v. So 9v goes in here and here. And then one's minus and one is plus. And done. Okay, 7. This one maybe looks a little bit different, but it's pretty much the same. You know, the square root of 4 is easy. That's 2, right? So definitely 2 goes here and here. What's the square root of x squared y squared? Well, the square root of x squared is x. The square root of y squared is y. So the square root of x squared y squared is just xy. And then 1 is minus, 1 is plus. How about this one? Maybe this is like, I think the square root of this guy is not too bad. The square root of 36m squared is 6m, right? What about this one, though? Maybe that's a little tricky. The square root of what squared gives you n to the 4? That's n squared, right? If you do n squared, you do 2 times 2 here, 4. So the square root of n to the 4 is n squared. So that n squared is what we want to put at the front here. And then 1 is minus, 1 is plus. Okay, so, and then the last 4 little questions for tonight are, 1 second here. Yeah. So I really want to emphasize that we always have to look for a common factor first. So these are difference of squares, but before we can actually do difference of squares, we have to pull out a common factor. So when I look at number 9 here, as my first step, I know it has 2 terms, but I can't do difference of squares because neither 50 nor 72 are perfect squares. But after I pull out a common factor, I think it'll be fine then. I think we can just pull out a 2 as our very first step. Pull out a 2 as a common factor. And this divided by 2 is 25y squared. And this divided by 2 is 36. And then I look at what's left over here and I ask myself, is there anything I can do on this? I can't do trinomial. I can't do grouping. But I can do difference of squares because each of these is a perfect square. So I'll write my brackets down to kind of set it up. What squared is 25y squared? That's 5y. I'll put that in both. What squared is 36? That's 6, right? And then 1 is plus, 1 is minus. I'll write plus here. I think on all these I wrote minus first and then plus. I'll write plus here and then minus there just for fun. Okay, so number 10. I guess we have the hint here that there's going to be common factors on these ones, so we need to keep our eye peeled for that. But like I mentioned before, on a real question, they're not going to tell us that. We just have to know that for ourselves. So is there a common factor here? Yes, z, right? Let's pull that to the front. And then we get x squared minus 25y squared. And this is a nice perfect square. Sorry, not a perfect. Remember, perfect square means this, right? This is not a perfect square. This is a difference of squares. What is the square root of x squared? And that's x, right? What's the square root of this? 5y. And then 1 is plus, 1 is minus, or minus plus, whatever. All right, so that's the answer for 9. That's the answer for 10. For 11, let's see what we got. I think z is common. Oh, sorry. 11 is up here. I just recopy 10. 36c, 121cd squared. I think C is all that's, 36 and 121. There's nothing common there, right? I'll just show you a little something here. On the calculator here, if you go to math, and then you go to num, and you go down to GCD right here. Oops, I pressed something weird there. Let me try that again. Go to num, go to GCD, press enter. Oh, what's going on? Maybe I have to go from this screen. So math, and then go to GCD. There it is. If you type in 36 and then the comma right here above the 7, 121, and we see that the common divisor is 1. So we can't pull out nothing from 36 and 121, but we can pull out a C. And so we get this. And this is a difference of squares now. It didn't look like it here, but now that we pulled out the C, now we can factor it. The square root of that is 6. The square root of that is 11D. And then a plus and a minus. And then the last question here for tonight is this one. So 20 and 5, we can pull out a 5. And I see a B in both places, so I can pull out a B as well. So our common factor is 5B. And then we get 4A squared minus C squared. And that is, that's a difference of squares now in the brackets. After we pull out the common factor, the difference of squares reveals itself. 2A is the square root of that. That's in front. And then the C is at the end, minus plus, or plus minus. Here I'm writing plus minus. Here I'm writing minus plus. I just want to emphasize it totally doesn't matter which order you write them, plus and minus. And that's all good. All right, so that's the last question for tonight. I hope this little review of factoring helped. And I'll see you guys on the next live stream. Have a good night.